Question number 43 brings us back to remembering our forces, force of tension in this case, and force of gravity. So we have this contraption where we have a force that we are applying physically to an end of the rope. The rope itself is fixed at one end, and there are pulleys involved. The first pulley is just supporting the rope and kind of provides the loop-de-loop. And then the second not only rests on our rope, but it also supports a mass of which is given to us as 76 kilograms. We're asked to figure out the force that we are applying, force of tension 1, force of tension 2, force of tension 3, and also the work that is done by the force by raising. The last part would be probably the easiest because the work that we do results in increasing gravitational potential energy of the object, which is mgh, and they tell us that m is 76 kilograms, 9.8 times 1.8. That's 1340 joules of energy. I'm going to actually go for question B first and figure out all the tensions separately, and then we'll get to force that we're actually applying. So let's concentrate on the mass itself. The mass is moving at a constant velocity, which tells me that force of gravity on it and tension 2 are identical. And mg is 76 times 9.8. When you multiply that, it is 745. Well then, if mg is 745 newtons, T2 is also 745 newtons. Notice that tension 1 is the upward tension in two parts of the rope. And actually T3 is just the same. It's all the same force. So therefore T1 plus, I'm going to call it T1 with apostrophe, will be equal to T2. So therefore T1 and T3 are both half of 745, 372.5. T3 is 372.5 newtons, and force itself is also 372.5 newtons. That's the beauty of running pulleys, because you give what is called a mechanical advantage. We raise this much, which is the weight of it is 745. If I just simply took a rope and tried to lift it, I would be forced to at least apply the 745 newtons, and to start it moving I would have to overcome that, but then just continue doing 745 newtons, supplying that amount of force for it to keep going at a constant speed. However, if I run two pulleys, boom, I just halved that force.